this video I'm going to be specifically making it for M105 at IUK. These topics are in section 7-4. This whole section has been dealing with radicals, adding, subtracting, multiplying, dividing these radicals. They also, in this section, start introducing some function notation because that's something that we've covered previously, and then also this idea of can you find the domain. Okay, so this is one specific example that deals with just something that's kind of out of the ordinary, just so you'll know how to handle this function notation. Alright, they're going to ask us to find f over g of x and the domain of f over g. Alright, they're going to give you an f function and a g function. Your f function is square root of 32x to the 10th. Your g function is square root of 2x to the 3rd. Alright, so the first thing you have to do, it says find f over g of x. Okay, so that's the first thing I'm going to do. I'm going to do f over g of x. Alright, which basically means what? Take the f function, put it on top, take the g function, and put it on the bottom. So I'm going to have the square root of 32x to the 10th. Alright, all over that square root of 2x to the 3rd. Alright, now since this whole section has been dealing with these type of quotients like this, so then let's go ahead and remember the rule that says if I've got two individual radicals, one on top, one on bottom, I can, if it's going to benefit me, write it as one great big radical. Alright, so if I write it as one great big radical, then I can do 32x to the 10th over a 2x to the 3rd. What that allows me to do is that allows me to work with this expression underneath algebraically. Okay, so 32 divided by 2 is going to give me a 16 underneath the radical. And then when dividing like bases, I subtract the exponents that are on my x, so I'll have an x to the 7th. Alright, now we want to keep going because we want to simplify this. Okay, square root of 16 is 4, so we know that's going to come out. Okay, now this x to the 7th, 7 does not divide by 2. I need to find the biggest perfect square root. So I'm going to take that exponent and I'm going to start decreasing by 1 until I find something that divides by 2. So I decrease to 6. 6 divided by 2, yes it does, it works. So that means that x to the 6th is going to be the biggest perfect square that's going to go into that x to the 7th. I'm going to have 1 x to the 1st there left over because when I multiply these two, when multiplying like bases, add those exponents, I get back to that x to the 7th. This turns out to be a perfect square root. So I'm going to have a 4. 6 divided by that 2 is 3, so it's an x to the 3rd square root of x. Alright, so I have found f divided by g. Okay, now what I have to do is I need to take a look at the domain. Okay, now here we've got to keep in mind, alright, that when I put this in the bottom of this quotient right here, that means that x cannot be 0. Okay, because if x was 0, 0 to the 3rd times 2 is going to give me a 0, square root of 0, 0. That means I would be causing a division by 0. Okay, so everything, the domain of this function is going to be everything bigger than 0, and I cannot include 0. Okay, so domain is going to be from 0 to positive infinity. And the part that you've got to catch is the fact that this is a quotient, and if x is 0 right here, you've got division by 0, and that's not allowed. So a lot of people will sometimes want to do a square bracket, anything bigger than 0 there, but we can't because it's in that denominator right there. So the domain of this function is going to be 0 to positive infinity. Alright, definitely thanks for watching. If the videos are helping, be sure to share with a friend so that they can benefit too. And don't forget to subscribe to the channel. Thanks.